The next thing that we're going to do is we're going to look at problems where we're given a percent and we're trying to find the observation that's associated with that percent. So let's say, for example, we wanted to know at what height do 25% of men fall below. So what height of men do we only capture the lowest 25%? In order to do this, we need to look at the percentiles in the middle of the z-table. So in the middle of the z-table are our different percentiles, and we have to find the one that's closest to 0.25 that represents 25%. From that middle portion of the table, we can reach out and find our z-score that's associated with the lower 25%. That's going to be negative 0.67. So the first quartile is 0.67 standard deviations below the mean, and then we can use that value to find what height is associated with that level of z-score of a z-score of 0.67 standard deviations below average. So let's do this for a couple of problems. I pulled up here the summary statistics for the heights of men and women again. And the problem we are looking at is we want to know at what height does a 20% of men fall below. So here we're given a percentile and we're trying to find the height that's associated with it. So the first thing that we need to do is we need to find the z-score that's related to 20%. So we're going to start by pulling up our z-table. So here is our z-table, and remember that in the middle are our percentiles, and then the z-scores associated with them are found in the first column and top row. So we want to start by finding the percentile of 20%. We're going to look for the percent that's closest to 0.20. So the value that's closest to 0.20 is here, 0.2005. The one next to it to the right of it is just slightly lower, and the one to the left of it is slightly higher. So we're going to use this value to try to find our z. And to find that z, what you do is you reach out to find the first decimal, so negative 0.8, and reach up to find the second decimal. So negative 0.84 is the z-score that we're looking for. So we found our z-score of negative 0.84, and that's for 20% of men that fall below what height. So we'll let x represent that height that we're trying to find. And the z-score is again calculated with the observation going first, the mean going second, and we're dividing by the standard deviation. So the z-score that's associated with this height is negative 0.84. That goes on the left-hand side. And now all we need to do is we need to solve for x to find the height that's associated with that z-score. So when we solve this for x, you can see that we find the height to be 66.85 inches. So at a height of 66.85 inches or below that, we find 20% of the men. So what this means is if you're a man that's 5'6", you're going to fall in the lowest 20% of men in terms of height. So let's try another problem. This problem focuses on the summary statistics for the women, and this time instead of using the z-table, I'll show you how to use an Excel program that will let you find the z-tables. So here we're looking at what height does 10% of the women fall below. So we're given the percentile, and we need to find a z-score that's associated with it. And from that z-score, we can then find the height or the observation that represents only the lowest 10% of women. So the formula that we plug into Excel is the normal inverse. Remember that we used the normal distribution to go from the z-score to find the percentiles. So we want to do the inverse when we want to get the z-score from the percentiles. So here we're plugging in the percentiles to get a z-score back. So we're going to type in equals norm inv, open parentheses, and then this first number represents that percentile. But the first number has to be given in a proportion, so the proportion of 0.1. So this first number has to be between 0 and 1, where 0.1 represents that 10%. The second number is the mean, so the z-scores have a mean of 0 and a standard deviation of 1. So these second two numbers will always be the same, 0 and 1. So pulling up an Excel spreadsheet here, we can type in the norm inverse, open parentheses, and our probability is going to be 0.1, so we're looking for the lower 10%. The mean is 0, the standard deviation is 1, and then this gives us our z-score that's associated with that lowest 10%, so negative 1.28. So now that we have our z-score that's associated with the lowest 10% of women, we can use our summary statistics to find the height that goes along with that lowest 10% and that z-score. So on our left-hand side, we'll put our z-score, and our right-hand side is the formula for the z-score. So our observation goes first, and that's what we're trying to find. X here represents that height that's associated with the z-score. The second number is the average height of women, so 64.1, and then what we divide by is the standard deviation of women's height. So when we rewrite this equation and solve for x, what we can find then is the number of inches that height represents. So 60.58 inches is the height that represents the lowest 10% of women. So if you see a woman that is 5 foot or less, she falls in the lowest 10% of women. The last important thing that I want to point out to you is that the problems that we've done in this video all focus on finding a height that falls below a certain percentage. And sometimes the problems that we're given, we're looking for something that falls in the upper tail or fall above a certain value. To attack these problems, you want to use that 100% rule. So to find the height that's associated with the upper 10% of women would have the same answer as one that looks at a height of 90% of women falling below. So again, we're using that concept that 100% of the women fall within the range of possible heights. If we only want to look at the upper 10%, that's going to give us the exact same number as looking at the lower 90%. So what this means is when we're using our z-tables or we're using the Excel values, we need to remember that the value that it's finding is everything that's below that z-score. And if the problem asks for something that's above, we need to subtract that from 100 to find the correct probability.